You might have noticed that I left out the entire middle of the periodic table earlier. Not only did we not write any oxidation numbers above those metals, but we also didn't use them in any of the examples. And that's because they have a slight tweak. So most of the metals in D block have more than one possible oxidation number, which means that you would have to be given more information to know how to use them when making a chemical bond. Most of the time, by more information, what I mean is I literally have to tell you what charge that particular ion has. So you can see in these two examples, copper, which comes from D block, has two possible charges. You can have a copper with a +1 charge, or you can have an ion of copper with a +2 charge, and that's going to change how it bonds to other elements. So chlorine, I do not have a oxidation number on because you are expected to know that particular oxidation number. If it's in group 7, we've already labeled those as always having a -1. So what that means is, in our first example, if copper and chlorine have a 1-to-1 ratio, then this particular molecule of copper chloride is going to be CuCl. But this one on the right has a +2 versus a -1. So that means this ion of copper is going to bond to 2 chlorines and not 1. The issue that arises here is, how do we distinguish between the two? If we're following the old rules, then copper keeps its name copper and chlorine changes the end of its name to IDE, but that you can't have two molecules that are different that have the same name. So what we have to include in the name of transition metals is a Roman numeral that represents the oxidation number of that ion. So for example, in the one on the left, we have a +1 charge. So that means next to copper's name, we need to do parentheses Roman numeral 1. Whereas the one on the right, we're going to include a Roman numeral 2, and that distinguishes the copper on the left from the copper on the right. So for naming this compound, okay, like earlier, oxygen, you need to look up that oxidation number. It's in group 6A, so it's always the same. So if we have that 2-to-3 ratio that we talked about earlier, okay, that means the symbol for this compound is going to be Fe2O3, but when we name it, it's not just iron oxide. Okay, we need to include a Roman numeral that goes with the charge that came from iron, which in this case was a Roman numeral 3. If we name mercury and nitrogen, nitrogen always has a -3. So that means it's going to be mercury 3 and then 2 nitrogens. Okay, mercury needs to have a Roman numeral 2 next to its name to represent that +2 charge, and then nitrogen changes to nitride. Fluorine is always -1, so this is going to be CrF3. The majority of its name, chromium fluoride, but then of course we need to include that Roman numeral 3 for the charge. Sulfur is always -2, so in this case, when titanium +2 reacts with sulfur -2, we have a 1-to-1 ratio, and the substance would be named titanium 2 sulfide. Titanium can also have a charge of +4, so this situation is a little different. Remember, we're always going for lowest ratio and how can we get these molecules to balance out. So in this case, if we need a -2 to cancel out a +4, we're going to need another -2. So that means we're going to have titanium with 2 sulfurs. But the name has to represent the oxidation number of the original ion. So the substance is titanium sulfide, but in this case, it's titanium 4 sulfide. What if you're given the name and you have to go backwards? It's pretty much the same process as before, except that you need to use the Roman numeral to know the oxidation number. So if you have an iron with a Roman numeral 2, it means +2. Bromine is always -1, so that means this is FeBr2. If you have a copper with a 1, it means copper +1. Sulfur is always -2, so this is Cu2S. Chromium 3 is going to react with oxygen to make this molecule. Nickel 3, Ni+3, nitrogen is -3. If the numbers are a 1-to-1 ratio, then that means we just have one atom of each. Gold is Au +1, chlorine -1, so once again, 1-to-1 ratio means that we just have one atom of each. And last but not least, if we have platinum here with a +4 charge, and oxygen has -2. This is going to need another atom of oxygen to cancel it out, so it's going to be 1 platinum with 2 oxygens, and then we use that Roman numeral 4 to distinguish the platinum. Unfortunately, there are always exceptions to every rule, and in this case, when we talk about naming transition metals versus naming representative metals, that means that we're going to have some transition metals that don't need a Roman numeral and some representative metals that do need a Roman numeral. So one thing that I want you to add to your periodic table is that there are 2 transition metals that you're expected to know always have the same oxidation number. So in the box for zinc, we're going to add a +2, and then in the box for silver, we're going to add a +1, because zinc always makes a +2 and silver always makes a +1. What that means for their naming rules is that we leave that Roman numeral off. So if silver's always +1 and oxygen's always -2, we don't need to call it silver 1 because we're just being redundant. Silver is always 1, 1 always goes with silver. So that means the symbol for this substance would be Ag2O, but then when we name it, we do not need to include the Roman numeral, silver oxide. If you see silver in a compound, you need to associate that with the +1 charge, and then chlorine -1 means that this would be AgCl. The same rule applies for zinc. So if zinc is trying to bond to bromine, we're going to need 2 bromines every time because zinc is always +2. So naming it, we do not include a Roman numeral. We just say zinc because it always has the same charge. And if given the name, you need to associate zinc with that +2 symbol. So that means this would be ZnS for zinc sulfide. The other exception is the opposite problem. What if you have representative elements in those A groups that can have multiple charges? There's only 2 that you need to recognize, so we're going to do the same thing. On your periodic table, I want you to add these possible charges to the boxes to help you remember to include the symbols in the names. So for number 50, tin, we're going to do +2 and +4. And the same 2 possibilities for lead right below it, +2 or +4. Those 2 metals can make either of those charges. So in this case, you have to be given this information because you would not know it on your own. So if we have a tin with a +2 charge and a chlorine, which is always going to be -1, then that means that we're going to have SnCl2. But we cannot leave the name tin chloride. We need to include that Roman numeral 2 since tin has multiple options. If you see the Roman numeral 4, then you should know what to do. If you have tin, that means it's a +4. Oxygen's always -2. So in this case, we would need 2 atoms of oxygen to balance out the 1 tin. And the same rule applies for lead. Iodine's -1, so in this case, we would have 1 lead and 4 iodines, and when we're naming it, we need to include that Roman numeral 4 in the name to distinguish it from the other possibility, which is a 2. Pb +2 because of that Roman numeral. Phosphorus is always -3, so that means lead 2 phosphide is 3 leads and 2 phosphorus. And that concludes the lesson on how to name binary ionic compounds.